So, good evening, everyone, and welcome to the 309th episode of Gyan Pravah, a Foxy presidential initiative, wherein we have a discussion with different eminent people who have worked in the field of women health or otherwise in other fields but are women in themselves. And for this 309th episode, we have today Jaya Panwalkar. She's the ex-site leader of NVIDIA, and she has done a lot of work in supercomputing. So we are going to discuss about mega minds, supercomputing insights today. Before we actually start with the discussion with Jaya Madam, I would like our Joint Secretary, Dr. Ashwini Kai, to say a few words on behalf of Foxy.
Hi, good evening, madam. This is Dr. Ashwini here, the Joint Secretary of Fogsi. Actually, every time our President, Dr. Sunita Tandulwadkar joins, but unfortunately today, madam is held in a cesarean section. But 99% of the time, she's always there. And this is
Yeah.
her brainchild, where she has given all the 31 committee chairpersons the 30 days of the month, where they interview one eminent personality every day. So this has been going on since 10th of January 2025. And our last episode would be that 10th of January 2026. So today it is Chaitanya's turn, who is a committee chair for endocrinology committee. And as Foxy, you know, madam, it is an organization of over 46,000 gynecologists spread across India. And we have been working very passionately this year on the concept of preconception care, which is taking care of the women before they actually get pregnant. So this is the theme of the year for Sunita, madam. She's also been working very passionately against thalassemia, which is another major cause for babies dying of thalassemia and needing blood transfusions every year. She's also worked very effortlessly for cervical cancer vaccination, that is vaccination against HPV. So we have a Nirmal Banaras Abhiyan, where we have adopted this town of Banaras or Varanasi, and all the doctors there are trained to diagnose this early and to vaccinate each and every woman. So this is a pilot project which started in Varanasi this year, and probably by the end of 18 to 26 months, we are aiming to eliminate at least HPV from this town of Varanasi and then replicate this same project all across India. So these are the various projects where Foxy works for women healthcare. And I'm sure your podcast is going to be very interesting. I think I'll join in from the viewers link, and all the very best, Chaitanya, for this podcast.
Thank you.
so much.
Thank you, Dr. Ashwini, for those kind words. And let's move on to our topic of today, that is the discussion with Jaya Panwalkar, madam. And we are going to discuss about supercomputing insights today. So before we actually start with the question and answers, let me introduce my speaker today. And I welcome you, Dr. Jaya, on behalf of the Endocrinology Committee, Foxy, and the Foxy initiative of this podcast. So Jaya Panwalkar is a globally acclaimed technologist. She is an innovator and national leader in high performance computing, artificial intelligence, and semiconductor systems, with a legacy spanning more than 4 decades. Her work bridges deep engineering, national capacity building, and global technology leadership. She is a United Nations Fellow. She holds a degree, advanced degree from the College of Engineering, Pune, Colorado State University, ISB Hyderabad, and an executive management program from Stanford University. Her early career at the Central Water and Power Research Station established her as a pioneer, leading India's first import substitution random sea wave generation system, developing earthquake simulation technologies, and helping implement some of India's earliest supercomputers. In the corporate world, she served as CTO and board director of Irish multinational Pace Soft Silicon, driving breakthrough multimedia and semiconductor solutions for global brands including HP, Motorola, Palm, Asus, and Samsung. She later led the company's acquisition by NVIDIA, founded the NVIDIA Pune Design Center, and built it into the company's largest engineering hub outside of US, catalyzing over 100 patentable innovations and establishing 85 plus NVIDIA academic labs across the country. At the national level, Jaya serves as the Technology Advisory Board and chairs the HRD Core Expert Group of the National Supercomputing Mission, shaping India's HPC that is high performance computing and AI ecosystem. Under her leadership, over 25,000 scientists, engineers, and researchers have been trained, and 9 national nodal centers have been established across premier institutes. She is a former chairman of the Board of Governors of SVNIT, appointed by the President of India. He continues to advise leading corporates, startups, and global education initiatives, including N4L, that is Numeracy of Life. Jaya is an acclaimed speaker known for her ability and simplify complex technologies and inspire diverse audiences. Her mission today is simple yet powerful to give back by empowering the next generation of India's technology leaders. Wow, that's a very impressive CV Jaya madam, and we are very fortunate to have you today for our podcast. Uh, Madam, actually, when I first discussed with you regarding the podcast a few days back on phone, and I got to know that you have worked a lot in supercomputing. The first question that came to my mind was, what is this supercomputing? So we all have learnt about the computers. We started with the PCs, and then we moved on to the laptops, and then now we have moved on to these handheld devices. But still we say all of them are some kind of a computer or the other. Then what is this supercomputing? How it is different than what we had in the past? If you can just explain to begin with, so that I am sure there are many of us in the medical field who don't know actually what supercomputing is.
Okay. First, let me thank Foxy for inviting me for this talk and giving me the opportunity to work with another domain of people, that means all doctors, on the technology part of it. To be very frank with you, we both are mutually connected by technology in
Yeah.
many ways. That means the technology that you use during your examination or judgment or operations is all connected to what we do in our engineering field. So from
Okay.
that, I'll just like to start my talk. One of the thing is that the concept of supercomputer came in around 1960, when the computers were built, which were really like demons, which were
Hmm.
occupying large space. And they
Hmm.
were called supercomputers because normal data machines were very slow, very small, and these machines were able to do the calculations very fast. So what is
So
the
when you say
fast
slow,
computer
it is
of
the
that generation is supercomputer.
okay.
So I
Okay.
just wanted to give you an example.
Okay.
When I was at Central Water and Power Research Station,
Hmm.
we wanted to do mathematical models of the ports and harbors.
Okay.
And for doing the layouts, you must have seen the walls, you must have
Hmm.
seen the jetties of the
Yeah.
boats,
Yeah.
and that type of structures are established with the help of sea wave studies in the
Hmm.
laboratory fluids. And
Okay.
that time, some of the things were not on physical models, some were on mathematical model. So for
Okay.
mathematical model, we wanted to use the computers, which were very
Okay.
powerful, so that we
Okay.
can have smaller parts of the jetties reproduced on the computer.
Computer. Okay.
The more you want the smaller part to be reproduced, the more power you want to calculate. That is very clear, I think. So
Yes.
basically, that time we went for a supercomputer. That
Okay.
supercomputer was occupying a room of about 5,000 square feet.
My God.
And it had
Okay.
a 400 hertz power supply instead of 50 hertz power supply. So it
Okay.
required separate motor generator set. Then it
Okay.
had a cooling water pipes inside the computer, which
To
used to
keep it
take up the
cool.
water at 4 degrees centigrade, and
Acha.
it used to get heated and it will leave it at 11 degrees centigrade.
Okay. So
So
there are
it
lots of
had a
heat
humidity
generated as well.
control.
Hmm.
Yeah, it had humidity control between 45 percent to 55%. Then only it will work.
Okay.
And the
Okay.
capacity of that computer was about 3 million instructions per second.
And what was the normal computer instructions rate at that time?
That time, the normal computer rate was about 10 kilo instructions per second or 1
Oh,
kilo instructions per second. So this was a
okay.
supercomputer. It
Supercomputer.
requires
Okay.
super power, super manpower to manage it.
Hmm.
Now I compare with today's uh, Smart Dragon, that Qualcomm's Snapdragon.
Hmm.
Qualcomm Snapdragon has a capacity of calculating 3 into 10 raised to 12 instructions per second.
Oh, so not
So from
million, but into 10 in raised to 12.
12.
Okay.
So that is still not a supercomputer today.
Okay.
Today we have a supercomputer from NVIDIA, which
Okay.
is having a chip size, a smallest chip size of about 750 millimeter square, single chip,
Okay.
and which has
750
about,
millimeters. Okay.
yeah, and which has about 208 billion transistors.
Okay.
The chips that I used to work on were having the transistors initially in the college, 8 transistors.
Okay.
When I took over NVIDIA, that time we brought out a chip, supercomputing chip, that had 8 billion transistors.
Wow. 8 to 8 billion.
And now it is 208 billion. So this
Amazing.
supercomputing phenomena is just
Hmm.
moving across the world, and that is offering people like you in medical field lot of new things, new medicines, newer and newer things, and the demand on supercomputing will be very high.
Okay.
So
So,
I cannot say that this is today's supercomputer is the ultimate one.
yeah, but as you rightly put, that simply put, supercomputer is something which is the fastest for that
That
time.
era, that
That
era.
time, or yeah, that era, so that will keep changing. The terminology will remain the same, but the what you can say, technical specifications behind that supercomputing will keep on changing as per the change in the era, or as fast as they will become.
Right. It is not only the technical specification, it is the technology inside itself
Okay.
changes.
Okay.
When I was in 72 and I was building 10 transistors in a
Hmm.
circuit to make it as a computer, the transistor was of this size, one transistor.
Okay.
And now
Okay.
imagine that on 750 millimeter square chip
Chip.
of this size, 200 billion transistors. So the technology
And
of making silicon transistors smaller and smaller has increased. Now to
okay.
take the power of that 200 billion transistors out to the users is also
Okay.
very high. So the
Okay.
technology behind whole thing changes. Like
Okay.
your operations are becoming more and more and more complex.
Okay.
Similarly, the technology behind is changing more and more and more complex.
Okay.
So I
Awesome.
think I made
Yeah, I got
supercomputer.
it. I got it. So when I was discussing with you, I also had this, question in mind. When you started your journey as an engineer, I don't think that there would be many women who ventured into the engineering field as such. How was the acceptance at that time for you as a woman in the field of engineering? Did you face any hurdles or any, backlash from the society that, oh, this is a girl and why you are doing an engineering, or, even at your first job site, or your first job, did you have any of that
Uh,
sort?
to be very frank with you, while getting the admission
Uh,
into engineering, I had a lot of resistance from society. My parents were filled with so many doubts about my career getting into engineering, that what I will do, how I'll have husband, what type of jobs I'll be able to do, I will
okay,
not be able to be successful, or those kinds of things. But fortunately, when my first job after my master's came, my director was very much for having girls in the
okay,
community. But
okay,
one thing was there, he was for, but with the colleagues. It
mm,
was a hard time.
mm, mm.
Definitely, it was a hard time. And because, but one thing is there, that there was a hard time. There was hard time in meetings, that they never used to take us seriously. But after the meeting,
Whatever you said.
whatever you say.
Uh, okay.
But after the meetings, most of the time, you have to be bold and we have to get over that, um, because we have to understand that the society is of that type, and we have to get over the fear of literally explaining our things, whatever our points are. And if you
Mm,
go above your capabilities, they accept it. So there was
okay.
no resistance from that point of view.
Mm, mm, mm,
But
mm,
I had
mm.
faced the resistance when I moved from, at the age of 50 years, moved into a corporate world.
Okay.
When I
Okay.
had all my associates of the age of 20, 25 MTechs from all engineering colleges, and I was 50, I was doing a technology for video on mobile phones. That time, camera phones were not available. We were
Mm,
developing the new things. And that time, they used to feel that, what is this lady of 50 years going to do in this new technology? So, one of the things I
okay.
learned over there is that reskilling and upskilling is very important.
Yeah.
And
So
I
that's a
think
very
that in your
important.
field also, this is important.
Absolutely. You have brought out a very important point that age is not just a number. Even though you have a certain age, you should be up to mark with the current time, and whatever the new technologies or advances happen in your particular field, you should be updated with those technologies and the knowledge, so that you are with them in time and not behind. And that's how you can overcome the resistance of these new generation people who feel that, I mean, she is a 50-year-old lady, or I am a 50-year-old doctor. Now he doesn't know the how to do, say for example, how to do robotics. That's not his game. He won't be able to do that unless I prove that yes, I have gained that knowledge which has come recently, and
Yeah.
I am mastering that. It might take a little more time for me to master as compared to a 25-year-old lad, but still I'm trying and I'm getting it. That will help overcome that resistance, and then we can grow together, or we can put your experience and their enthusiasm together for the betterment of the society, isn't it?
Yeah, yeah. And another thing is that my experience tells me that maturity plus capacity to upskill makes you move very fast up the ladder. I remember that my first project that I delivered in France of
Mhm.
that camera-enabled phones itself was a great success, that we became the partners with Intel and Microsoft.
Okay.
And
Okay.
that made gave so much confidence to my team, that they were
Mm,
really very, very affectionate to the things that I was leading about. And it just goes. Afterwards, there was no problem. They were just
okay.
with me.
Okay.
But I faced that problem.
Yeah, I know. But well, I mean, hats off to you that you overcame that your resistance, or you overcame that stigma of being a woman into a field of engineering, and you have proven yourself in this field. And I'm sure many young girls would be there to take inspiration from your example, and go ahead and do wonderful work in the field of engineering. Medical, we already had quite a few of girls joining the medical
Yeah.
stream, and now you won't believe, but my daughter is in her first year of MBBS, and out of 250 admissions, 192 are girls in the
Wow.
class
Wow.
and that's the changed scenario today. So almost 80-85% of the admissions are by girl students, and only maybe 15-20% of them are boys today. That's the scenario in our field of medicine, and I'm sure the same thing might happen in the field of engineering as well. Okay, so moving on, I just wanted to know from you the journey of this supercomputing worldwide, and how all of this started in our country, how we are today placed as compared to the advances in the supercomputing technology worldwide?
Okay, so one of the things I would like to say is that worldwide, the supercomputing is moving fast, and India is not very much at the back end or anything. India is
Okay.
also moving very fast. So
Good
first
to
and
know.
foremost of all, I would like to tell you the story of how NVIDIA, it's the world's largest company
Yeah.
by its market cap. It's more than $5 trillion. The first company to reach $5 trillion, and to
Wow.
start this type of company who was really right from the beginning at the top of technology in India itself gave me some challenges. And I would like to discuss that from India's point of view, how we should take care of those challenges is
Hmm.
one of the examples that I have said, and that's why actually I have been accepted worldwide as a leader. So
Okay.
when we started NVIDIA Design Center, we started for a camera-enabled phone technology,
Okay.
and we were 65 engineers. So it was that time in computing something called as GPU. CPU is
Okay.
normal computer. Whatever you call it
Yes.
as computer is central processing unit, CPUs. You must
Correct. Correct.
Intels and other things.
Correct. So we know this
NVIDIA,
term. CPU
yeah.
is very
So
known to us
NVIDIA
now.
brought out a term called GPU, graphic processing unit,
Oh,
because
the
that term is come up because of it accelerates graphics pipeline on the PCs or
okay.
on the devices.
Okay.
So it was popular for gaming,
Yeah.
PC gaming. It
Yeah.
was very, very popular.
Yeah.
But
I
NVIDIA,
remember this because when my son wanted to have his first computer, he was very keen on, Baba, I need the graphic card and I need the graphic card with this specifications so
yeah,
that I can, play games on the computer. And I was strictly against it. Why you want to play games on the computer? But
absolutely.
that's,
You said you were strictly against it. So basically, NVIDIA came with this graphic processing unit,
yeah.
and in 2006, there was a person called Ian Buck was working as on his PhD at
Hmm.
Stanford University. He with Jensen Huang, who is the president of NVIDIA,
Hmm.
they thought that if this graphic processing unit have pixels horizontal and vertical, that means it is a
Hmm.
matrix. So
Correct.
if that is a matrix, it can do parallel operations on each elements.
Hmm.
Because if matrix multiplication means rows by columns, rows by columns, rows by columns, can be done
Column.
parallelly. So
Yeah.
he had that concept that why not we use this for computing simultaneously.
Hmm.
Instead of CPU calculating one after the other, we
Hmm.
can have simultaneous calculation.
Acha. So that was a
So
basic difference in the concept, one after the
yeah,
other compared
and
to
that
simultaneous.
revolutionized supercomputing.
Okay.
And that he brought out a name called CUDA,
Okay.
Compute Generic Architecture, for a
Okay.
language with which the programmers can program in CUDA the GPU for parallel jobs.
Okay.
That is called GPGPU.
Okay.
And that is used for mathematical models.
Okay.
And therefore, if you consider, even if you can consider the uterus,
Hmm.
if you have to model a uterus, you can
Hmm.
have vertical, horizontal lines, and
Yeah.
and whatever happens at the small, small grid points, do the parallel calculation. You know what is happening inside the uterus. So that is the
Okay.
concept. So
Okay.
there were
Okay.
computational fluid dynamics, several problems of that type, and that
Okay.
GPU then started. Intel started integrated GPU and GPUs, powerful GPUs, more powerful GPUs, and then came the
Hmm.
revolution of AI.
Okay.
Because
So
why
AI is a continuation of supercomputing. Can I say that?
AI is possible because of supercomputing.
Okay. Okay. So if supercomputing wasn't there, AI wouldn't have born.
AI wouldn't have got the what it is got. And now
Okay.
what is happening is that this supercomputing computing power is going to smaller and smaller devices. All your
Yeah.
machines have the supercomputing power. So
Yeah.
there we can put AI.
Yes.
So basically, the difference between just parallel computing and AI is that it just doesn't compute, it remembers.
Oh, okay.
It has a capacity to understand from its previous days by connecting, like in our brain, neurons get connected
Yeah.
by the help of connections. And when
Yes.
they get connected, they remember the connection.
Yes.
Therefore, a mug shown to a small kid, if he's shown the mug 10 times, 20 times he himself says that it is a mug. He
Yeah.
doesn't have to calculate that.
Correct.
Same thing has been put into the computer languages so that it remembers.
Okay. Okay.
And that is where the compute power comes
Okay.
in preparing the neural networks as happens in the brain.
That happens in the brain. So we are trying to replicate what's happening in the brain, but maybe at a much faster speed or
Not even faster speed. Actually, our brain has lot of neurons and lot of connections. It has
okay.
about, I think, 87, I shouldn't tell you, 87 billion neurons, and I think we call it as 100 trillion connections or something like that. But we can't have that, but we can have as external algorithms to connect that brain.
Connect that.
And
Okay.
also we have now data available.
Hmm.
And
Hmm.
data can be put on the computers in huge data sets.
Hmm. Hmm.
So huge data sets, compute power available, and algorithms available. All these three things
Together.
aids computing totally to make AI.
AI. Okay.
So supercomputing AI is together now.
Okay.
I
So it all
hope
started with
I hope I am not
no, no.
too much into it.
See, if I can understand, I am sure all of us who can would understand that. So it all started with this graphic processing unit what NVIDIA brought, and
Right.
that's how the things started. So the this handheld device and the camera which is there and all what it can do today with the camera all started with your invention of the GPU and the NVIDIA. Can I
No,
say
no,
that?
camera started, it didn't require GPU because
Correct.
initially
No,
for
with the
speaking
camera
you don't
backend.
require that much power.
Right. Right.
But to now you require streaming algorithms and other
Okay.
things. So
Okay.
NVIDIA type of companies started producing GPUs which are very fast and very capable, and same generation in a small chip. Small
Okay.
chips goes into the small phone.
Mm, mm,
Big chips goes into the supercomputers.
okay.
So this is
So,
how the things happen.
okay. So, what is the scenario of this supercomputing in our country? What are the government initiatives in regard to this supercomputing? And have you seen any change in the recent times? Uh,
Absolutely, absolutely.
okay.
I will
So,
tell
can you
you, when
just
I
elaborate
started
us?
NVIDIA Center, there was no GPU knowledge or no graphics knowledge in the country.
So, it
So
was
it
in
began
2006.
2006. So
Yeah.
I have to start with meeting all the IIT heads, NIT heads, all central universities. GPUs were there in Vikram Sarabhai Space Center or something like that, where there
Okay.
was very high-end research going on. You know, now also the space research is somewhere
Absolutely. Some at a
above
different
our
level. Yeah.
normal level.
Yes.
So I have to go there, and I started about setting up labs of NVIDIA
Mm,
into those organizations. And I set up
okay.
more than 87 labs
Okay.
in the country.
Okay.
And
Okay.
that allowed NVIDIA's knowledge to be known across the country.
Mm,
And at the same time, the scientists from IISc Bangalore and MIT and Department of Science and Technology were forming supercomputing consortium in India.
okay.
It was formed in 2010 only, but it
Okay.
was approved and the sanctions were given in
Mm-hmm.
2015.
Okay.
And it was known as India National Supercomputing Mission,
Okay.
NSM. And
NSM,
it was
National
about 5,000,
Supercomputing Mission.
about 5,000 crores of grant was
Right.
targeted at it.
Wow.
And it started in 2015. There were four core groups. One core group was for hardware, one core group was for upskilling and training, one core
Okay.
group was for research and development, and one core group was for application development, where I will come to the applications that
Yeah,
medicine we
yeah,
need.
yeah, yeah, yeah.
So these core groups were formed, and we started, instead of buying supercomputers, we were started building supercomputers.
So that was the basic difference. Initially,
Yeah,
we used to buy it from outside. Now we built it ourselves.
yeah. And
Okay.
actually, first building of supercomputers started actually in 1990 when Vijay Bhatkar was there, and he
Mm.
built transputer based. That was another chip called transputer based supercomputer.
Okay.
But it didn't stand that much in the market, and it was because the manpower to handle it was not ready, and it was
Okay.
very difficult to parallel program it for the
Okay.
programmers.
Okay. Okay.
So that was gone. And then now in the National Supercomputing Mission, we have now about 37 supercomputers
Wow.
installed already for research and academicians.
Okay.
And we are having a total capacity is now about 40 petaflops. And by the end of
Okay.
next 2 months, 60 petaflop more is under commissioning.
Okay.
It's at the end of commissioning. So total capacity for this will be about 100 petaflop.
Okay. And you said when we were discussing that this mission, National Supercomputing Mission, will end in 2025 and a new
Yeah, new mission will
mission will
start.
start. Okay. So what
So
what is
that
that?
this mission, because this mission has a end goal. When the end goal
Mhm.
is achieved, but still there is so much in supercomputer to be
To
done.
do.
We will
Okay.
have next phase of supercomputer where we
Mhm.
will be building our own chip for supercomputer. So we
Okay.
will build our own GPUs in the country. We will build
Wow.
our own processor in the country. In
Okay.
addition, we will do a lot of research on quantum computing in the
Okay.
country because that is
So,
another era of supercomputing.
okay.
So our progress in the country for supercomputing will continue.
So we are reducing the reliance on outside sources for building
Absolutely.
all
So we
these
are, see,
technologies.
all these supercomputing missions are for making India Atmanirbhar.
Mm, mm,
As of today, another important thing is that in AI market, now Ambani is setting up a 1 gigawatt power consumption for that supercomputing station called as data center is
mhm,
about 1 gigawatt. So that data of our country will
mm.
remain in our country and will not go out.
Okay.
And
Okay.
we will have our own power of computing.
So how was your experience? You have been on the committees of this mission with the government. How has been your experience with the government and how the things are moving,
I will tell you one thing, it's not that there are no hurdles, but
right?
there is so much follow-up from PMO's office
Okay.
on these things. Who is the chairperson of supercomputing mission? He is the
No.
person from Niti Aayog.
Okay. Okay.
There are
Okay.
four
So
members Niti
direct
Aayog committee, out of which one is the member or chairperson of the
chairperson of the.
supercomputing mission.
Okay.
So that
So
means that
there
is followed at that level.
that level, yeah. So that the funding and everything is not hampered and other
It is
things
not the
are
funding, it is also the progress on technology
progress
front
on
is being
technology.
watched.
Okay.
First
Okay.
supercomputer in phases, that we were divided project into phases. For first phase, was there any delivery delay? Was there for the
Mm,
second phase, was there any delivery delay? Whether the funds were released, but whether the technology was progressing in the correct way.
mm,
Because
mm.
manpower has to be created that speed, right?
That's true. That's true.
Because our
So,
manpower, like our semiconductor is to be built, doesn't mean that semiconductor gets built. We need to have
yeah,
that much capability developed so
right.
that the chip can be built over in the
So
country.
that they are very keen on developing that technology in our own country, and that's why they are so much keeping a close eye on what are the developments going on.
Yeah, and we have developed indigenously one computer called Rudra computer, Param Rudra.
Paramrudra, yeah.
And about 6,000 Param Rudras are installed at various places in the data centers of the supercomputers.
Okay. Okay.
13,000 researchers have been working. 18,000 PhD students have been already working on this.
Okay.
27,000 people are working. There is a lot
A
of progress that has
lot of
happened.
progress. Okay, so let's come to the health sector now, and I would like to know from you how this supercomputing, has helped in the field of medicine and healthcare as such, and what is your take on that?
To be very frank with you, in supercomputing, usage of supercomputing in the healthcare is a very, very important aspect. For protein folding, I don't have to tell all the doctors that what protein folding does and what wrong the protein folding happens, what all
Hmm.
happens. It can create diseases like Alzheimer's and Parkinson and
Hmm.
cancer and so many other things. But the
Yeah,
protein folding is a very, very complex process. It happens in body very fast, but
hmm.
it happens to
To
be
recreate it
simulating
outside,
outside is
hmm,
very
is
difficult.
very difficult.
But because of supercomputers, the time that it was requiring years of operations. I remember 10 years back, Berkeley University has asked for the supercomputing power. Every PC should be kept free at night so that the power of every PC can be used for protein folding operations so that the
Okay,
results will come.
okay.
That was the situation. And now this happens in days.
Hmm.
So
Hmm.
actually there was I'm giving you data so that you will remember that. There was a computational chemistry Nobel Prize of 2024, that means last year's, was given to
Hmm.
Dr. Baker. He has developed a technology for developing new protein, which can be absorbed by the body
Hmm.
in a
Okay.
in what you call it as um, I don't remember the word, medical word, but it can be injected into
Okay.
the body as a medicine so that
Yeah.
the disease, so that the wrong protein that has been folded
Replaced.
wrongly,
Yeah.
it can act to reverse the operation. So he
Right.
got the
Right.
Nobel
Right.
Prize for that. And the another
Okay.
one got the Nobel Prize who was researching with him for finding out the wrong protein at the fastest speed. So both
Okay.
these things together can now produce the result for the cancer and these types of operations very quickly.
Hmm.
So I know
Very
that
quickly.
you are doing so much work for ovarian cancers and tumors and
Yeah.
everything. So these are
Yeah.
really revolutionizing the technology.
Okay. Okay.
Another
So it's
revolution.
working in, yeah,
Okay, go
it's
ahead.
working in both diagnostics as well as therapeutic options for that particular disease or pathology.
Yeah, pathology. Another thing
Okay.
important is that they have developed one which I have seen, which I have seen is that operational, it was in the lab, of course, it was not in the actual practice. But
Hmm.
when we do a heart surgery, the
Hmm.
body goes into the heart-lung machine and heart
Yes.
is made stationary to operate.
Yes.
But there are a lot of risks involved in that.
Yes.
So robotic heart surgery with 12 robotic arms and lots of sensor on it has been
Hmm.
developed in such a fashion that the
Hmm.
arms move
Hmm.
in in connection with the heartbeats so that relative velocity of operation is zero.
Oh.
So that
Okay.
our
Okay.
doesn't have to be moved out.
Moved out.
You can do the operation on the spot.
Acha. So we don't have to use the heart lung machine.
Heart-lung machine, correct.
Acha. Okay. Oh, that's amazing. That's amazing. That's something very new to us. Maybe, as you rightly said, that it may not have come yet into practice as such, but they are working towards it in the lab. And once they have that confidence, probably we can see it coming in the actual use in future anytime, right?
And I have seen also one more thing, which is very interesting, is
Hmm.
virtual reality and augmented reality and the things where by putting the camera over here,
Yes.
you
Yes.
see the things. So I have
Yeah.
seen myself in Berkeley's lab
Hmm.
itself, a surgeon having the goggles on his head and
Yeah.
doing a surgery on a virtual baby.
Okay.
And
Okay.
virtual baby was moving in all directions. It was really, really a virtual baby.
So it's like
And
a
the
virtual
nurses were
simulator.
reading instruments and everything. So it is for the practice
Yeah.
sessions for surgeons to
Mm-hmm.
do delicate surgeries.
Okay.
So
Okay.
this is also one of the things which requires supercomputers. It is not a job of like a desktop machine or something. It can happen with that.
I agree. Even with the robotic surgeries, which we do, before we can actually start using robotics on the humans, we have to undergo model-based or module-based training. And
Yeah,
in that, there are, as you rightly said, the virtual simulators.
yeah,
So we have to actually sit on the console, and then there are no actual humans, but a
yeah,
simulator which is at the back end, and we have to recreate the entire surgery on that simulator or on that virtual human before we pass that test. And once we pass that test, then only we are allowed to go ahead and use that robo for actual surgeries or live surgeries. So
yeah.
that's exactly where your supercomputing is helping us
So backend,
in
that's
building.
actually in the initial discussion, I said that what you are using and what we are producing is very much connected.
Connected. Exactly.
So
Exactly.
to be very frank with you, when we have to work on these kinds of applications, we have to understand sometimes some terminologies of the
Mm,
doctors, and doctors
mm.
need to understand the terminologies from our side.
Yes.
I want to give you one more example, which is also really astonishing. There
Uh-huh.
is a now a concept of digital twins. Have you
Okay.
heard of it?
No,
So
no.
actually, the digital twin concept came first into China, where they produce the digital twin of a Shanghai city.
Okay.
That means whole Shanghai city was simulated on a computer. And if
Okay.
we have to construct a bridge or a tower, you can see that the Shanghai, that whether the bridge is how it is obstructing the flow of
Traffic.
vehicles and everything
Okay.
has to be done
Mm.
over there, and then it is actually constructed. But that was the initiation that went into medical field, and they are creating digital twin of a human
Oh, okay.
based on the data coming from MRIs, muscles,
Hmm.
CT scans, pathological test, blood test, urine test, everything together, all that data is combined in data analytics form. And a
Mm.
digital twin is prepared so that the first injections with a difficult situation to be given or first treatment to be given can be given
Will
to
be
the
tried on
twin,
those. Okay,
digital
those
twins,
twins
and then those can
used
be
in the
studied.
actual humans.
Yeah. So this is something which is really amazing.
Yeah, and it's crazy to even think of such things are going on somewhere, and it would be of help to us in future. So that's what I was going to come to. That what do you think is the future of this supercomputing? Where is this going to end at or does it have an end really, or not? And what's all this going to have an impact on the human future as well? I always keep on thinking because so much of things are going on in this supercomputing, and most of the things are now being done by these computers. Will our brain will remain, same active, or the synapses and the neurons would simply decrease in size or number because of not using it adequately?
To me, it is that the neurons that we have in our brain
Hmm.
and the connections that we have in the brain are too much more compared to what we have achieved so far. And
Okay.
maybe next 10 years at least, I don't feel that we will be able to do anything. Another important thing is that when these data centers and computers and other things are built, they consume lot of power.
Okay.
They consume lot of water.
Mm.
So their environmental impacts are difficult to handle.
Mm.
So we cannot increase them enormously in any way.
Mm. So there are
Because
limitations.
we have limitations, and we have to progress the technology in such a manner. Like I told you, the GPU, graphic processing unit, it is a general purpose unit, right?
Yes.
Now NVIDIA and other companies have read of doing is neural processing unit.
Okay.
That means they will not be used for any other general work where they are wasting power.
Ah.
They will only do the neural processing unit work,
Mm.
so that the power consumed by the data centers will be reduced.
Okay. Okay.
Then there's the models which are generalized models using lots of things which are unused, kept unused but use power, are removed.
Mm.
And distributed computing is there. Now, NVIDIA's one handheld computer is like our set-top box,
Mm.
which
Okay.
is having 1 petaflop AI capacity.
Yeah, capacity.
So
Okay.
these can be on your tables.
Yeah.
When you see the sonography results, it can
Mm.
calculate on huge database what are the abnormalities seen of this type of things, and give you lot of conclusive guidance. But ultimately, decision is yours.
Okay. So it will not happen that the humans are replaced completely by this
No,
AI or intelligence,
no,
and we become redundant in the field of medicine.
no, absolutely not.
Okay, because that's a fear which we have, and there are certain branches which are more prone for this disruption than others, like pathology or radiology. Their AI is coming up so fast that many of us are just thinking whether these branches would really exist for us humans or not. It would be taken over completely by AI
I
or
will tell you,
machines.
whatever thing is repetitive
Mm,
can be replaced by AI.
mm,
Whether you are making AI to think, you will be thinking, you will be doing the job.
mm, mm,
Pathologists may
mm,
be replaced.
mm, mm,
Says, yeah, our operators
mm.
doing quality control, they will be
Mm.
replaced
They will be replaced.
by robots.
Mm,
But the people who are thinking like digital twin, they are not be replaced.
mm,
So upskilling and reskilling is more and more important with high speed.
yeah.
I am
Mm,
75 years old.
mm.
If I have updated myself from 8 transistors to 208 billion transistors, I think it is possible for all of us to keep updating ourselves.
Absolutely, absolutely. And that's important if we have if we have to remain in this field, and we have to be there. Otherwise, as you said, we will become redundant. So
Absolutely.
one of the reasons why you should be updating yourself is because if you want yourself to be in this race and you have to be existing in this race, you need to do that. Well,
Yes.
what the last question, what I would ask you for today is, what advice would you give, to the new generation or to the new upcoming, need not be doctors, but any field from your experience in supercomputing, that what all things they should learn, if they have to be successful or if they have to be growing in their field, respective fields, whatever they are.
One of the things I will tell you is that the basic sciences, the basic arts, the basic medicine knowledge, the basic engineering knowledge is going to be very, very important.
Mm,
Computer is a tool. The
mm,
people required for enhancing that computer tool will be limited, but the people in all these areas will be very important, and they have to learn how to use the computers
mm,
for
mm,
their job. because the coders will not be required in future.
Okay.
The medicine people maybe directly with some agents reach up to
Mm.
the supercomputer and get their work done. But that
Mm.
much capability has to be developed.
Mm.
So
Mm.
people in all fields
So
are
rather
required
than
to be
so rather than opposing it, we should embrace the technology and see
absolutely.
how we can use it to our advantage and uh, for the benefit of the society at large.
Yeah, I will tell that.
Okay, okay. Well, it was wonderful having a word with you, Jaya madam. We have almost 8:55, so we have a few couple of minutes more left for us. But I would like to stop here. And it was wonderful having a word with you. We got a different
I
perspective,
hope that you have
deep
got
diving.
some different scenario as you have
Yes.
Megaminds talk.
Yes. So now we got to know what a mind can do. And one thing what I realized from your talk was or speech was that our mind is still much, much, much ahead of what supercomputer we have today. And it's a long way to go for the supercomputing before it can actually match how fast or what all things we can think about or how the human brain works. Well, that's something which is incredible because I always used to think that array, this is now so fast, this is developing so fast that probably we are going to be redundant. But that's not the case. What I got to know from you that we are far away from what actually a human mind uh, can do.
Yeah.
Yeah, yeah,
And remember reskilling and upskilling.
yes. That's one word what I will remember with me for a long time. Rescaling and upscaling. Absolutely. Thank you so much once again for being here and accepting our invitation for this podcast. Thank you.
And thank you so much for giving me the opportunity to come and talk to the doctors. I hope that doctors will see this video and get to see what in the medical field also the changes are happening because of the supercomputers and
Yes,
make
Doctor.
use of that for their good and for society's good.
Yeah. So Dr. Sunita Tandulwadkar, the president of Foxy for this year, whose initiative is this podcast, would surely love to hear you. The recording is always available. Unfortunately, she could not join today, but I would like to thank you and thank her as well for this initiative, what she has been taken for the last almost a year or so. Thank you so much.
Thank you. Thank you so much.
Thank you.